Hello. Does vinegar go bad? Apparently it does not. Cool. Cool. Okay, so today I'm gonna make a thing that converts floats to integers. I seem to do that a lot. Back and forth. Two-way conversion. God, my camera is like I'm delayed. I don't know if I need a new capture card. Probably need a new capture card. Um, yeah, it just doesn't work anymore. I think it's probably kernel software updates and stuff that broke it. But like, I don't know what to do about that. Okay. Well, I know what to do to start out. I did this wrong. Oh. So this is every single. Jeez. Every single one of these is supposed to be a multiply by 2, but I wrote divide. Oh dear. I wrote divide by 2. Whoops. That would have been hard to debug. I just kind of like was scrolling through my code. Okay, that's good. That's good. Indeed. Okay, so the tests, huh? It's gotta be messed up. Okay, so I have the plan here. So digit shift. This is most significant bit less than 0. So bit, yes, and then take bits rounds to the nearest multiple of this one. Digit index. Yeah. Because see, like, shift down, shift up. So it's like divide by 8, then multiply by 8, and subtract. So this number will be smaller than this number. So this is a number between 0 and 7. So if the most significant bit E plus Bing plus F Why do I want the most significant bit? Shouldn't I try to get the zero? Plus mantissa bits. E. Hmm. I'm wondering if I remove this and that will give me the bottom bit. And then you do this. So it's like trying to write some number of bits, 53 bits, right, to this number that's more than 53 bits, or maybe not. So shift the man. Yeah, that's right. I couldn't do this before because get mutt index. I couldn't do this before because the digit shift was too big, 64 bits. But now the digit shift is it's small, 8 bits, 1 byte, and notably, it's smaller. So this is a 64-bit unsigned integer here, the mantissa. And but there's only 53 bits of information there. So I can shift by 8 bits and it will fit. There's even a few extra bits. So I can align with the 8-bit digits in the binum number. These ones. So there's a list of bytes. Yeah, I'm wondering. Yeah, I should go with the least significant. B. Plus F. Because if it's at that least significant bit, then I can use that as the like shift factor. Because it's like this. Yeah, it's how much it is above a multiple of 8. Difference with the multiple of 8 below the number, or 0 if it needs to be. Okay, and then I would go like, oh yeah, dude, go up to Mantissa bits. Let's try it. I thinking I am knowing what I am doing. So then most significant bit, Mimi when. Methinks. What is E? I-16? Right? Yeah. Okay. Okay. Indeed. Okay. So N times binum friggy diggy. Binum digit width. So if the biddy, so this is actually least significant bit now, or no, it's like, is it zero indexed? Hello, Frost. I'm updating a library that got a significant update. Binum. This is it. Look at this. Yeah, there it is. So this guy wrote 13,000 lines of code to update his library. Basically rewrote the whole library. Actually, it's probably fair to say that he did rewrite the whole library. Which is pretty cool. It's the math library I'm using for strafe client physics. It was changed. So you know how in base 10, each digit goes from 0 to 9? This library was using 64-bit integers as digits. So the digits would go from 0 to 9 trillion or whatever the number is. It's much bigger than that. But now each digit goes from 0 to 255. So the internal representation has changed. And shouldn't this be not inclusive? Yeah, so the internal representation has changed. So my math library that depends on this math library, which strongly couples with the Binum library, I have to refactor it to work with the new internal representation. And I might already be fairly done. I just have this like complicated algorithm that converts between a floating point number and a fixed point number. Okay, so least significant bit. That's like the if we read a number, it's like, hi, I'm a number 10024. 4 is the least significant bit. Great. If the most significant plus mantissa bits. So if none of the digits make it into the number, then it's too small of a number, and the closest representable number is 0, but that may not be what you want, because it's actually a very small number rather than 0. And 0 has a different representation. And of course, there's too big of a number as well. So if the least significant bit, greater than or equal to the final most significant digit, if it's beyond the most significant digit, then it's too big to represent in our number. Yes. Okay, so then digit index yes, so it starts there. Indeed. Yeah. How did you know? Okay, and then we shift the ding dong. That's right. Aligned mantissa is equal to m shifty difty tig bits. The 53-bit mantissa has room to shift by 0 to 7 bits. Indeed. So alignment, we'll call something like that. Indeed. And then none of this is real. Instead we go high for digit in digit index digit I guess we call this like LSB digit index. And then this is like LSB alignment. And then we can call Gabagoo MSB index. MSB digit index is least significant bit plus a mantissa bit. Yes. Do I need to do this? Mantissa bits expr. Isn't that just a thing and it'll just show up as a thing? Indeed, indeed, indeed. Okay, so that's the MSB. So we go from the LSB to the MSB. And we say, is that here? Did I mess up here? Okay. Hey, write your digit. Do it. Aligned mantissa. Ah, 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 ah. Ah, ah. So, okay, problem. One list is indexed by, and the other one is zero indexed. Oh, what if I say digits iter mut, and then freak zip aligned mantissa 2 bytes, and then we can say like this, and then we say digit equals m digit semicolon. Actually, wait a second. This is copy from slice. I'm a big dummy. Copy from slice. Except the slices aren't the same size. So mem copy, mem copy, mem. Expected use size. Ah. 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 Positive number or negative number. So, oh, look, we have to edit this. I guess I can say most significant bit. Most. You're the most significant bit. Indeed. Indeed. Use size. Okay, so this is actually as I32. Is it gonna troll me with this? No. Okay. Most significant bit. The most significant. Why don't I like use good numbers like, or variable names, LSB, MSB. Aye, come back. So this is like, the type bing bing cannot be indexed by bong bong. I32. Oh. Uh, okay, so this is always positive. This is but this is something else. Hi, Adam Chatham. This is a I-16. How would I... can you shift using a U size? Surely you can. Okay. 3 U size, shift left by 8 U size. Yep. Okay. Yeah, cause like no, that's right. Actually, wait. Oh, I don't know anything about code, but I watch your vids to chill. That's great. I make them to focus. I'm the one who needs to understand the code, so you're in luck. You have no responsibility here. There is no obligation. So the thing here, so imagine we have a crazy number, and there's like digits in the number. Let's say our number has 8 digits, and we have like a floating point number that can like move around. So this is like, so this would be the number 1 in our representation, and like this. So these are fractional bits. So this would be 1. Okay, imagine that this is like binary, 0 or 1. This would be 1.5. And then this would be 1.75. Yeah. And then closer to 2. And then this would be 3, of course. So what's happening is LSB, we have this like floating point number. Let's say that it has 4 digits. It's just a binary number that has 4 digits. It's getting like shifted along here. I'm like trying to align it with digits. So like it might line up right here, and the digit would go, and each digit would like get copied in to the number. So the point of the floating point is it has this shift. It gets shifted along by its exponent e, whereas the fixed point number does not. It is fixed. It doesn't have an exponent. I'm playing surf right now, actually. Grinding. Okay, so the LSB is the position of this digit. So it's the shift plus the floating point fractional part. So F would be like 4. 1, 2, 3, 4. So the exponent, so then it lines up. Let's say the exponent is 0, and then F is 4. So we have to go 1, 2, 3, 4. And it lines up right here with the 1's place, or the 0's place. So it's the 0th power. It's the 2 to the power of 0 digit. So the thing is, the least significant bit, it's possible for it to be less than 0. So that would mean like, oh, it's shifted off the end of the number, and this bit gets thrown away. And we only take these 3 bits and put them right here. That's really annoying how it like does that. This song is very ambient. It can hardly be called a song. What does this code do in game? This code is for converting between the number representations. So in Roblox and everything, they use floating point numbers because they are very convenient to work with. So they can be really big or really small, and they're great. But they have lots of edge cases, lots of problems that can occur. Like if you make it too big, it just says, "Oh, I'm infinity. This number, it's infinity. You did it. It's too big." And then now you have this like infinity that's just sitting in your math. If you're trying to say like, what's the position of this object? It says, "Oh, it's infinity." Great, just great. So I like to work with fixed point numbers where it has a very strict range of values. It can only go from like negative 65,000 to positive 65,000 or whatever range. It's strictly specified. There are no special cases and there are no ways it can fail other than dividing by 0. But they're not compatible. This creates the size of things in game. This is a it's a representation of values, like 3. So in floating point, the 3 has certain 1s and 0s in memory, and I have to like change it into something else, into my representation, the fixed range value of 3, because the 1s and 0s aren't the same between the 2 different types: floating point, fixed point. So the point of this code is to convert. It takes a floating point number. It's like, oh, this is the mantissa. This is the exponent, and it's a negative number. And then it goes and like makes the 1s and 0s for the fixed point number, and then now I can work using fixed point numbers because I've converted it from floating point. This is used for converting Roblox maps. So like in my game engine here, excuse me, this is a Roblox map, B-Hop Arcane, and Roblox uses floating point, right? But my whole game engine uses fixed point. So at some point, I need to convert the numbers. Arcane, yes sir. And that happens in the Roblox loader module. The responsibility is to convert it from the Roblox world to the Strafe client world. Is this texture missing on Roblox as well? So like imagine like Roblox is using base 10 like normal people, and I'm using Base 12 because it's so much better. I'm sort of contrarian. Kind of. Oh yeah, I was supposed to go load the map and look at to see if the texture is there. I immediately start jumping. Ah! Arcane? No. Cool map. You can see the difference. Oh yeah. Texture is there. Aha. Wait, but it does have it. Okay. That's the fabric. Okay, yeah, it is missing a texture. That's the fabric texture. Huh. Excuse me, map maker. There's a missing texture. Excuse me. All right. So we're shifting our bits. They're shifting. Oh boy, the bits, they are shifting. And I was trying to think of a way to represent the least significant bit. With only positive numbers. So the MSB will always be positive. It can always be positive. You can't end up with a negative number and have a successful conversion. But the least significant bit can. Must be the same. The problem is if. Wait a second. Actually, this has a bias. Yeah, so this starts out as a positive number here. Ah. Uh, I think I like that. So this is subtracting those thingies. Mantissa equals U32. So it does fit into U64, but we can make it. This is a byte. U16. Okay. Why don't we do this? And this can stay unsigned. Um, U16. Same with this one. Indeed, indeed. Indeed, indeed, indeed. So now I need the bias to be part of the bias. Toe bias. Toe. Bias. Bias. Can you see literal? You can say literal. I snee. Okay. Okay. So now we have the bias. And then this is unbiased exponent. This is SOS band. Tell me if you still care. Damn, I just know the samples now. Tell me if you still care. Oof. Ugh. Okay. Ooh. E. And then this is already juiced, which is what I was thinking about what I wanted. So I could saturate the indices. God, I'm like so close to being done, and then I just invent a way to block my progress. Oh my god, bro. M E. Okay, so we do actually do E as you said. I guess it doesn't matter. It doesn't matter. Why don't we actually say that this is U8? Holy. One, two, 11 bits. Cool. So this works like this. Ah, god damn it. I'm so used to having my own playlists. I'm just like listening to random songs right now. SoundCloud. R R R R R R R R. So MSB is always positive. But then LSB is actually allowed to be negative. Oh, I can actually put the bias on the left-hand side. That's true. True. So I can say like plus bias like that. And then LSB can stay positive. Okay. So we haven't needed to use negative numbers at this point. That's crazy, bro. It's tricky because it can get cut off from the top and it can also get cut off from the bottom. So if this, yeah, no, this is the digit range. So this is like according to this, and it's copying the bytes. And But I need to do like a sub slice. Well, we dodged negative numbers so far. How do I clip the sides? I could just do a for loop, but memcopy is like a juicer. Mega speed. Oh, else. Oopus. That's true. And this is LSB biased. Not the true LSB. So I could do saturating sub. That would work, but then I wouldn't know the index within the source bytes. Within this so-called aligned mantissa. Oh crap! Cribbity crap. Well, oh no, it's as usual. Okay, no, we're good. 24. Is there still room? 24, 32. Interesting. Oh wow. Wait, can I just actually straight up just chill like that? Holy moly. I think I can actually be chill like that. Excuse me? What are you talking about? Pretty good. I-32 is out of the equation. Signed shift is out of the equation. Good. Yeah, sure is a lot easier to work with signed integers here. You want the old LSB alignment. Or should I squish and slice? I feel like squishing and slicing negates the copy goodness. And I should just 0 plus 1 type situation. LSB, LSB, LSB. LSB. All right, let's do a for loop. This can come back if need. De loop, de loop, de loop, de loop, de loop. This is const. While loop. While. Uh, um, Indeed, 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 indeed. So then we say digits. Bada bada bing. Bada boom. Mutt. Mutt, mutt, mutt. So what is the index? Oh, I kind of want that code back. Give me that. So we need this, but without underflow from the bias. So I have to subtract bias from LSB bias, but I only need the alignment. So I can actually extract 3 bits Oh, true. I can just extract it straight up. Plus, yeah, man. It's plus. Oh no, it's minus. So okay, is that okay? Is it okay if it underflows and then I just grab the last 3 digits? That's Bing chilling, isn't it? Because it's 2's complement. Has the same representation. If we do, we don't need the indeed. We don't need the digit index. We can just minus, oh dear. LSB, it can just wrapping sub bias. And then this is -1. So we take the last 3 bits of the subtracted bias, and that gives us alignment. The bias is 1023, but that's okay. It's okay. 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 So now underflow is okay. We only need to know the alignment. Yeah. So we have I. Actually, methinks digit index LSB bias checked sub bias pull minus bit width times I checked sub bias minus bit width times I is 4 8 32 127. This is 127, so 127 minus 32 is always positive. But this is like your minus. Oh no, I can just plus it. I'm stupid. There you go. What are you doing? Okay, LSB bias plus. There you go. So it's the least significant bit plus like that. Digit shift? Wait, digit shift. Hold up. Wait a minute. Hold up. Wait a minute. But like this, I mean, it's okay. But like, I mean, it's always +1. But then, right. We need to overflow in. No. Yes. Is that the same? I'm confusing. I mean, this will work. So this is bit index, then digit, bit index, digit shift equals bytes I. But then we can also overflow. Did we even use the MSB? We didn't use the MSB. Oh, and we also forgot the I. Checked sub. So, well, no, we can calculate this. We can calculate this. We can start I at that location. But like, oh my god, bro. Okay, so I think this can't just mem copy because of this idiot machine right here. Okay, so let's start the loop at the ith digit of the aligned mantissa which is a real sentence. Okay, this is equal to 0. Equals 0. Then freaky I should be able to do a saturating sub here that saturates to 0. Sure. And I actually need to manage the audio again. Okay, it looks like Firefox is going to music now, which don't like that. But okay. All right, well, let's get back to where we were. Okay. So when this minus this is equal to 0, solve for I. we can find the starting index. Really? Hmm. God, that just ruined my mood. Ruined the flow. Literal hardware failure. It's actually amazing that the developer of the desktop, I guess it's a window manager I'm using, tiling window manager, c- completely diagnosed the issue the issue, which only happened a single time. This is the second time it's ever happened. The it's like I every single USB device got unplugged from the computer. So like music kept playing. Well, like the music. Yeah, the music is also a USB device. Very irritating. That's a freaking Super Mario Galaxy sound. So how can I do this? Yeah, we're doing modular arithmetic. So this is bits, but we need to know bytes. Oh, I guess that's easy actually. So, I mean, literally, literally mega easy. Okay, I'll do it on another line. So it is bias minus LSB biased divided by binum digit width, which is also shift right digit shift. I is equal to this. Indeed. So this is where the checked sa comes in. LSB biased. F. Indeed. Sa 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 sa. Isn't that an underflow? The bias minus 1023. Wow. This goes bigger, right? It can be bigger than 1023. E. I guess I can yoink it. Give me that. Do it. Okay. 2046. Mm-hmm. So 2046 plus F, whatever F is. What does that mean? That means that... Oh, there it is. Plus... So we don't need MSB. This can just be an if statement. If this is less than that, if it's equal, that's okay. So if you subtract to the right hand side and you get a negative number, that's an overflow. So I do actually need the I. Negative, negative. God, I don't know, man. I need to do these one at a time. As in convert and these two conversions. Start index. How do we know the freak index? I don't know. Like, this is correct, but I don't know what to put in here. Right. So this is plus. So there's two cases. God, I want that old code back. This sucks. Okay, God. Okay, so if it's like this, then I is 2. And if it's like this, I is 0 and the offset is 2 somehow. How do we know? It's shifted by E. And then unshifted by F. Is that literally E minus F? E minus F minus bias? But what if we're over here? Then it's I starts at 2, I minus 2. Okay. Minus 2. Yeah. God, it's... I could do an if statement and 2 different while statements. Yeah. Positive numbers are hard. Never subtract. Man. Writing this algorithm over and over again. Like I've done it for ratios. I've done it for floats. I've done it for fixed point. I guess it gets better every time. My bits, the bits, not the bits. So I could actually, I could do the, yeah, I don't know. I think an if statement might be the play. Like it sort of just doesn't matter. I probably should have just done integers and then forgot it. So this tells us which side we're on. Bias minus LSB bias. Yes. So if LSB biased is less than bias, then we're under and I starts at 0. No, 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 no. We're under and I starts at something. Else I starts at 0. Mm-hmm. Indeed. So if bias is greater, then this is positive. And we can go yes, yes, digit shift. Come on. Mm-hmm. And then I, huh? So this is also the offset. LSB biased is there. I. So I. I don't know, man. It's so confusing. So the digit has to be less. Oh. Right. Semicolon. So this is true in both cases. So then swap them. Easy clap. Done. Yeah. Okay, there it is. With only positive numbers. Brain flex. Jeez. First digit of Mantissa is lower than first digit of fixed point. First digit of Mantissa is higher. LSB. LSB. Indeed, indeed. Nutty, nutty, nutty. Oh, I mean the whole thing with only positive numbers. That's pretty cool. Arr, 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 arr. Is this even right? Surely it's right. So if the LSB is bigger than the digits or equal, yeah. Homely momely. Um, uh-oh. You good? Did I edit the other one at all? Okay, so now into float, the other side of the equation. Oh my god, bro. Okay, what's the plan here? Copy the digits into the mantissa. Indeed, unsigned abs. Well done. So, yeah. Yeah, so I'm... Ooh. This might be fairly easy, actually. Because I already have the exponent here. Boom, got it. What is underscore 127? Exponent bits. I see. Fair. This should be a constant. Honestly, I want 8 and 11 instead. And we can call it bias. And it's this. Okay, that's the only spot it's used. Maybe not. Maybe I use the bias. Well, I need... This is gonna suck to debug. What's the order? Sine, exponent, mantissa? Is that real? I forgot. Where's the diagram? Where's the diagram? Exponent comes first. Wow. bias. So then I don't need any of that crap. It's literally just this. And it's GG. Oof. So we got that exponent type stuff. Unsigned plus bias. Ah. Easy. -1 minus f. Ah. That's not checked. What if? Bias. Right. Bias. So f is less than n. Yeah, no, this is not guaranteed. Is that? That's shocking. Is that for 0? It must be for 0. God, I should probably test the other one before I do this. So yeah, impl into float. Let's just say panic and call it a day. You good? Okay. Huh? Oh. Okay, whatever. What's that? Trait. 16 multiplicative. I bazinga. I see. Okay, so as is what is up. It's A as B, so it's something as bazinga. As as you as zero. What the smoke? T is a generic. Okay. T. Okay, so undo everything I just did. Well, I guess no. Okay. Cast from, and then as. Cast. Okay. You got it, boss. And then as from. Oh, I messed up actually. No, did I? From bits. One, yeah. Lol. From U64, eh? And then we can just say U64, and we're golden. All right. What was it? 396. Okay. Types. F 192 96. Oh, dummy. Dummy. One. Oh my god. Okay, I see. Vector const Okay. Okay, so first things first, we're gonna go into strafe project, lib, fixed. Yeah. And then cargo test, just like that. What? Why? Who did this? 427, 452. I don't know why that didn't catch. Why is this like this? Put it normal. My normal. Three. Oh. Now we should get the bad. You gonna buh? Wait, what? Oh. God. I got. Okay, so this is a feature matrix issue. God damn it. Okay, this is not wide mall operator trait method. But what if yes? Then feature yes, feature no. method, fixed underscore method. I have created a mess. I'm not following this. So this fixes the compile, which is funny. I might just leave it. And do test features. Explicit panic. Yeah. From F64, from F32. Okay, let's go. So it's too big and it's something else. Test 80. Okay, let's go. What is that shift? Oh, is that just... But why is this 4? Left. Is left... Oh, 4. Yeah, 4. Cribbity crap. What about the edge cases? Actually, if it builds now, well, frick, there's this as well. Hmm. Um. Should I do 3 instead? Yeah. $64. Anyone else? Maybe that's it. All right. Stuff. All right, let's do we have 17? Yes. FH. Oh boy. I love replacing numbers. Okay, good. 16,024. 15 should be good as well. Music's so quiet. Let's go. I know what that number is. All right, nice. Uh-oh. Now I've done it. Surely that's good, right? Very interesting stream. Uh-oh. Made lots of mistakes last time. That should be good. Put it back. Put it back. Okay, well. How come it's still trolling me? Error originated from macro. Huh? Is it trolling? Okay, it's just trolling. Okay, now we get into the meat. Indeed. Okay. Okay, so this is gonna just not work, but it's still cool to run it, you know? Suffering, for sure. Unused mesh query. Oh yeah, that's right. Unused face crawler. Real? Huh. Test. Boy. Nice little module. Okay. Okay, let's watch it break. Yes. Okay. Fixed 51. Oh. N? Oh. N. Yeah. And that's GG. Um. Explicit panic. Really? Huh. Well, I guess I gotta write the stuff. The shut up, please. I should really debug the other one first. Well, it's nice that I got the other stuff working. So it's say, what did it say? Tests. Which one is it? From F64 and from F32, line 43. Yeah. Yeah. 25F. LHS, RHS. So LHS is the 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 observed. RHS is expected. Yeah, okay. Mantis's bits. So it wrote it. I guess I could just min it. So this is the main case. Did I leave some beard? Seems like I did. Bye. L is B alignment. Bias. Right. 2FTC. Right. It's used for. Right. I do actually use floating point for the graphics. Merp. I don't understand why it's too big. Like this is what is this? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12? 12 hex digits is 6 bytes. And then this is 2, 3, 4, 5. And it's halved. So that's 5 times 4, 20. So it's 19 bits off. F64 is 6 bytes, which is 48 bits. Oh, huh, 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 huh. Oh, do I? Oh, I need to be using like the shifted, right? Okay. Aligned. Help. It's aligned. It's sub. Hmm. Indeed. So indeed, sub bias alignment. Mine is bias. Uh. Oh, actually, it is the same loop. That's crazy, bro. So I think so. This is in bits. Um, and our mantissa is aligned, but I guess this is the same alignment. We're throwing away 3 bits. So like it's literally the same thing. Yeah, so this is the top half and this is the bottom half of the same number. I don't understand. How does it start so far up? The LSB is way down here. And this is a tiny number, like 4. Okay. Okay. Six. 435. Oh, no. Oh my God, my stupidity. 39 is cool. 0, 31. Oh, 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 oh. Wait, why is F64 actually isn't that a good sign? 31. How do we end up with a 4 if it's 31? It's the D index. 31. Is this a... So in the old code, it said minus exponent bias minus mantissa shift. Because I was adding the mantissa shift to the exponent. $52, but both of them are the same. So it seems right-ish. 31. So the number we're dealing with here is 0.25. This is hex. S- 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 30 s- 30 wait 31 wait 31 tests 80. Oh, it's a massive number. Oh my god, bro. Okay, so how many digits is that? Does it say? Is that 16? 512. I don't know. That's divided by 8. 8 times 64. It's 8. 8 times 64. Okay, but now we have 64. So it's 64 bytes. Right. 64 bytes. 64 bytes. So 31. That's right. Okay, but the problem is the mantissa shift then? Okay, so I do actually need to minus the mantissa shift because it's starting at the most significant bit. Okay. Mantissa shift. Bias. Ah. It knows. I'm crazy. Oh, wait. Wait. Bias plus mantissa bits. Yeah. Is bias plus. So if you plus on this side, then that's the same as not having it at all. Plus mantissa bits. Okay, well, let's see. Ooh. Off by 1. It's pretty cool. That's pretty cool. Okay. I. Who gets the 1? Who did this? The the is is the old is there an offset in the old code by 1? -1. -1 is inside this. No. Strange. The 52? I don't know. Okay, so how would I make it smaller by 1? Well, no, it needs to be bigger by 1. So the LSB alignment needs to be increased by 1. So wait a minute. 52 minus. Wait, 23. Wait. 24. Okay. -1. So. Can I just smash that straight up there? Okay, now we're getting somewhere. $196 explicit panic. Oh, is it going 4th? Six. From F32. Into. Yeah, it's going back and forth. Okay, so all of these passed. Okay. Fix it. Fix from F32. Yay. Yes. Good. Yay. Okay, now I have to do the other one. R. Bytes minus 1. Ugh. Okay, thinking time. Wait a second. Oh no, it needs this. God, that was freaking crazy. I really did it from F32. and 64, and they use different integer sizes. That's really cool. Like this is a U64 or a U32, and the code just like swaps perfectly fine between them. And it only uses positive numbers. Ooh. This is sucky, but I don't really know how else to do it. Actually, let's ask AI. Go AI. AI. Go AI. Um. AI. I was thinking of like trying to ask AI, but then I felt I should figure it out myself first, and I think that's a good choice. Um. This code works flawlessly, but I want to remove the if statement. That generates to improve the memcopy section. Where the digits from m bytes are copied into all digits array. It would be nice to remove that if statement. It would be nice. I don't know what it's going to do. I think it's just not going to know what's going on and make up something BS. You know, just AI things. Reasoning. I'm reasoning. Guys, this is awesome. I don't need to look at this code. I should look at the other one. Okay, so this is right. We know that. So this is right, and this is right. Probably. So we just have to worry about the miantiestia. So Digit loop, copy the digits into the Miantia. So here's what I'm thinking. We copy the digits in and then just shift it down a little bit, a little bitty bit, and then yes. So yes, digit index. Hello, digit index. Hello, most significant bit. Yes. So this is like the how shifty downy. Um. Sigabigabigabih. Sibigabigabih. I. Uh-oh. Minus. Uh. Oof. -1? What? Is this... Am I tripping? Is this like this? Oh, did Russ say that? I don't know. I don't know. I am hoping this is like that. Because and then -1 is crazy. Okay, so total bogus. Saturating sub. Hmm. 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 Mm-hmm. Mm-hmm. Yeah, it'd be nice if I could like guarantee that the memory was there. But no. Is this correct? Most significant bit. So we got the top dog here. Okay, but let's draw a picture. So we have our picture. Really, man. It should be okay, right? Like, bah. Eh. So digit index and then downshift. This is not quite right. No. Well, no, this is that's true. This is the like sub digit alignment. Maybe it is okay. So this is the other way around now. We have this number and we're filling in the numbers into the float. This is a F4 float, 4-bit float. So downshift is sub-digit precision. This one has only bits. I think it's... How do you know? It's mentissa. It's the bits. Sub digit what? What? Yeah, I don't know what that's about. It should be carefully designed for the old way, but we have a new way. I'm so slow. Like, I remember that this like fixes a special case. I don't remember what it is though. This is into float. Saturating sub 1. No. Bit width. 64 minus 1. If it's 0, oh, if it's 0, then we just frick it at 0. Okay. So it's for 0. For 0. Which is obvious, I guess. To EXP code that handles 0 in a different way. There we go. Oh my god, bro. We need to copy some bits. I'm distracted. Someone is typing at me. Okay, so now I need to copy digits into Mantissa. Let Actually, I can probably do this, eh? Underscore. Not quite. It's const. Yeah, sure, whatever. Right, that'll work. Explicitly. Okay, so then we fill in the digits. Same stuff. We have our I value and our D value. But it's the other way around. Where's the starting point? Yeah. Yep. Okay, so minus bias. No, minus anticipate. It's yes. Okay, so it's like if how come the sub is here but not here? 0 1. I don't get it. So what's the case? Yeah, no, I'm confused by this. Zero. 0 minus 0. 1. 1 minus 0. One? Is that right though? One. I don't know. What's the case? If most significant bit is some manticipits. So I'm going to subtract manticipits from most significant bit. So if it's smaller, then you can't do that. Else, okay, let's write the dingus into the dungus. Okay, so this guy say okay, so if the most significant bit is less than anticipates, that means it's off the edge. Lower. Yes. So type situation. So it's MSB minus manticipits and digit shift. And whose is it anyways? So you start at 0 on the D and you start at on the So mayhaps this is correct. Indeed. So then mantissa is unsigned from Lee bytes. Uh-oh. Ah. Yeah, this is M bytes. For real, for real. You good? Expected U32 value size. Oh. MS bit width 30. Okay. Okay. Whatever. Okay, there's something. Downshift. Okay, so this actually needs to go downshift. There you go. Neat. Can I do underscore here? I'm guessing not. Okay. Z. Failed. Not big surprise. Mm-hmm. Mm. Macro it up, baby. Ah, What could go, like, so much could go wrong. Whoa, wait. Oh my god. It's close. Uh, so what if we don't do this? But, like, it's kind of random. Okay, print. Just print some stuff. Print. Zoink. And then I say Why? Why? So if Mantis is bigger, we've got an overflow. Yeah. Oops. Okay. Thinking. I guess it don't matter if they're the same because it's just 0, 0 row. So this is kind of the normal case. I guess I can just swap them. M. I'm not sure. Oh! Oh my god, it's juice. What? It's passing some tests. Oh my god. but not all of them. 250, 300 bits. Okay, this is so cool. This is a neat strat. It's so rudimentary. Why is it going crazy? Digit index 41. Down shift 7 2. This is like off by a lot. Two F64. Tets. This is one. So it went pass on both of them. Oh yeah. Let's see if it runs. Because like numbers are working ish. Actually, hold on. Bop. Shh. Go again. Dude, there's no way. I don't know. I have no idea what's gonna happen. Oh. File not found. Ah. Okay, now we get the panic that loads the map. No panic, huh? Oh. That doesn't look right. I think something's wrong. That doesn't look right. That doesn't look right. There's something wrong with that. I don't think that's right. I don't think it's supposed to do that. Why is it doing that? Oh my god, bro. Huh. This is fun. It's so cool that it works. If actually, hold on. If I do a debug build, does that show me an overflow? Cause like it's probably overflowing. I don't know. It may not be overflowing. Mm. It's not overflowing. Wow. Hmm. I'm I'm a little bit surprised. Well, if I fix up the floating point conversion, it should work. Oh, actually, I don't know that. There could be bugs elsewhere. Actually, you know what? Let's run the physics tests for funsies. Let's just run all the tests. Do everything. Just go. Brush. IZ. True. Uh, failed. Oh, it's failing fast. Uh, no, fail fast. Fail slow, please. Physiques. Oh my god. Whoa! All the physics tests pass. So, wow. Wow, okay. So, it's just the float conversion, apparently. I made no mistakes. Jeez. Wait, but this. No, okay, right. These are like buggy. What happened to the music, man? What? Huh? Alright, what time is it? 10:15. Jeez. Oh look. What did he say? Is less. Huh. Huh. I mean, it did what I asked, I guess. Oh yeah, copy from slice. Oh, true. Wait, count. Min. True. Right, but I don't know. I thought that slicing this hard. Yeah, would be I like the compiler would be able to do it better, but it might not be able to do it better. Mm-hmm. That's pretty good actually. As U size. Um, I don't think that works, my good man. This is not a mask. Yes, it got this wrong, but that's okay. Interesting. Also, can use like eye size. Well, yeah, well, I size negate. There's ways. There's ways. Um, AI. Welcome to AI. Honestly, its idea is not bad. I'll think about it later. I. I. Okay. Oh, it's just a bug. It's bugged. But it works half the time. It works every time. And like, is it saturating sub? I don't know. How is it so far off? Like, it's perfect for some of them, and then it's so far off for others. I just had a crazy idea. I think I can actually do this way better. What was that music? I see trees are green. Hmm. Actually, hmm. Why would you put that in your song? Bites, bites. I mean, you know what? They're separate cases. Uh, mm, eh, mm, ah. So, yeah. Uh, mm. So it's, I mean, it's you and as, and then I think so. It's not actually. Uh, uh, int from bytes value dot to ly bytes semicolon bint as int f. And then you get all of the bitty bitties. The bitties. Well, oh, wait. Oh, it was fine as it was. Never mind. I didn't understand what it was doing. Okay, so it was already that. Yeah, okay. I see. Never mind. It was already doing that. Okay. Well, I don't know what's wrong with this or how to debug it. I guess I just why? Why? From F32. Which one is it? 1, 2, 3, 4. Wait. The very first one? Oh, no, 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 no. Okay, it's this one. 30 F into. Float into. So that's from float. But then. So this is. Okay, this is into float. Into float. Into float. So this is from float, but it's also doing into float. So we start here, F32. Max gabagoo is truncated into this value. Left is observed, right is expected. I actually don't know which one it is. One. Okay, so it is this thingy. Most of it is 63. Really? 63. 63. Okay, right. It doesn't include the sign bit. Okay. Maximum 63 downshift 7 digit index 7 digit index yeah. I mean, yeah, we just don't really care about that. It's not used. Okay, so then I am ID M. M is my bytes. That floaty boaty bytes. Wait. Huh? M. Huh? Huh? I don't actually know what happens. This is different. I am 4. 32 though. I am 4? Why does it do that? 7. To me, when I see I am 4, I think, oh, it's already too big because m bytes length is 4. Where did F32 go? Let's do this one, man. See, it's 4. So nothing happens. It doesn't write anything into the bytes. And then it just makes it unsigned. So this is 0. Uh. 63. What do you mean 60? What do you mean M4? That doesn't make sense. D. That's on D. This is not right. Anticipits. Most significant bit minus Manticipits. Manticipits is like 24. So that's like... Isn't that D? Are we scuba dubering? Like D, this sounds like D bits. But like no, okay, Mantissa is lower. The LSB of Mantissa is lower. Mantissa. How did we go into case 2 when we printed most significant bit, right? 63. 63 is less than Mantissa bits. False. 63 minus Mantissa bits. M. No. That's D. No. Wait, 0. I am confusing. I'm not following the logic here. Okay, so this is the picture. These are our digits that we have in our fixed point number. And this is the floating point number digits we're trying to, well, floating point mantissa. It just pretend it's like this is 4 bytes. It's a U32. We're going to shove it into the mantissa of the float. And like the idea is that we copy the bytes straight down into the mantissa with this while loop. If the most significant bit in this number, so this would be byte number 4, which is bit number 32, then our mantissa only has, if it's a float 32, only has 24 bits, 23 bits. So 32 is bigger than 23. So this is false. So this is the wrong case. If the this is just the other way around straight up. I'm just gonna write it like this because it's more obvious what's going on. So now we start D later. Okay, so I had just written it backwards. For real, for real? Why was it working ever? For real, for real? D4. Okay, now we have something that makes sense. D4. Oh, it worked. Me think. Because it went on to number 2. And then it died. Okay, most significant bit, 64 bits. Okay. Fix it. Yeah. So number 2. It hits a special case since it's not representable as a positive signed integer. Don't be doby do. Huh? Assert. Huh? Overflow. Huh? Indeed. Huh? So it wants an overflow. Oh, to do don't return an overflow. Oh? Eh? Where? Huh. Min hits a special case since it's not representable as a positive sign integer. Okay, before I go do this, let's look at more dingus on the dongus. Okay, we're still failing there. 255. Okay, so it's giving a number. Probably it's a wrong number. What number? Min trying to. What am I doing? Min. I am minimum. Is negative unsigned abs. So you get unsigned abs. That's good. And now it's a big number. Unsigned. You take the bytes. It's a colossal number. It's a power of 2. And what did he say? To do don't overflow. Number 2, 64 bits. I underscore D5. I'm thinking we need a -1 somewhere. 7F8. Id 5. 64 bits. 5. Like, is it maybe like -1 or something? I don't know. To do, don't overflow. Well, aren't I glad that I wrote that? Oof. Negative, right. Okay, what actual number is this? It's a 64-bit, which it's like 32-bit. So a 32-bit negative number, that's 2 billion. 2 billion. Okay, so we're on this one. 2 billion. Babadi. 2 billion. Isn't that just I-32 min as float situation? Into F32, try into. Oh, there we go. Give A. So it's like off. Oh, is that? Is that this? Wait. Into float. Oh, that's this. Overflowing. Hold up. Testing. Min try into. So that's float into. So that's the other one. Yeah. So this is this one. Overflowing negative. Hits a special case. Don't. I said to do. Don't overflow. Okay, so it's like in this one, it's going. Oh, am I hitting a case? And it just breaks. I might just be hitting a case. Okay. I think that this remains a problem. And it's just like not very important. It would like add slowness to everything for one single number. There's probably a way to do it good, but ugh. What if you 2's complement negative number? I don't know. What am I looking at? I'm looking at the other one. I'm wondering if the bug is in here from float. Meep, meep, meep. Was it? That's not correct. So I think the is actually in 2F32. Let me smash this. Wait, what? Just A, man. Who? Yeah, this is an interesting case. So we don't actually care about that. I see. There we go. F is I32 min as F32. And I believe this will fail. Yes, see? What the hell? Huh? Why is it a bigger number? What? Um, but all the other tests pass. But I guess it's because they're ginormous numbers. I see. Okay, we have a case that fails. Yeah. So it passes this, fails this. Which I am going to do here as well. I want to see that. What happens? Eh? How? Huh? Uh-oh. It would appear it's mega broken. Oops. Oh, I didn't just do this. This is obvious. Okay, actually this one, I'm going to say it's F. Like, why didn't I do this? This is so much more concise. I can't think. Okay, so both of my float converts are broken. Yeah. I will definitely need to like make tests for the specific failures. Or I guess it is failing tests still, so it's okay. failing tests. I mostly accomplished what I needed to. I wonder if these tests would have passed in the before times. Let's see. It should easy pop onto master branch. Oof. Oh, right. Not quite. Rah. Oorah. Oh. Okay, hold on. Hold up. Wait a minute. These things have different names in this world. Okay, so now oh, they do pass. Okay, that's what I wanted to know. It's wrong. Let's see. What if I do this? Oh, 003. 125. Looks like it's the same. Well, there's a lot to figure out. I would love to do only positive numbers once again, but I'm out of juice. God, I want to work on the Roblox cash grab game. Such a slog. Alright, well, it's good. Hello AI, this code works flawlessly. Oh, I forgot to update it. We have a new version. How many code lines change? 645? That's not too bad. What's all the new code about? What do you mean there's 100 extra lines of code? Usually that's what happens. The code just always grows. Because I guess there's a couple comments there. That's a nice block. That's not more lines. Where are all the new lines? Okay, that's a little bit. I mean, I guess the little bits that I saw can make that up. Yeah, it adds up to 100 lines of code so fast. I wonder if the square root would be faster. I never thought about using shifts. Zero. Why don't I just use is positive? Zero. Comp. Oh. Oh, this is not square root. Like I have is zero. Node? Wait, what? Oh, it's self? Ah, it's so tempting to clean this up. Is positive. Is zero. Don't need that, right? Hmm. Okay. Let's see. I will end the stream now. I did write the functions that I wanted to write, but they don't work yet. It will take more effort to work through the problems. We'll leave that for Monday. Okay. BNum is an exciting update for me because I get to make the physics better. I think I'm going to just not do graphics work. I'm just going to immediately dive into physics, finish up this refactor, and then try and fix some of the 5 main physics bugs. Hopefully no new physics bugs get introduced. That would be bad. I really, really want the physics to not be buggy so that there's a game so that I can make the rest of the game. Because the game, you can play the game. Look at this. issues. Physics bug. 5 physics bugs. This one is new and somewhat important. It'll happen occasionally. This one is probably the most important bug to fix. Oh, well, this one is also very important. This lets you surf if I fix it. So yeah, basically this one and this one are very important. Incorrect feb for nearly axis aligned mesh. These might be the same bug. Yeah, so if I can fix those 2 bugs, then I have a game. And I can start making other bits. It's been so long since I started this project. So many interruptions, so many other cool things that I made, so much progress on the project itself. I said 5 years when I started the project. I was like, yeah, I think it's going to take 5 years to make this. And that's sort of like uninterrupted. And I was very uninterrupted for, what was it, like 6 or 8 months or something? It was going great. And then interrupted. And now the feelings are different. Like, I still want to complete it. But I guess I've gone through like phases where I feel less capable. So there's like feelings involved instead of just like doing the good work. It's going to be a journey for sure to keep working on this. 2 bugs. And then I have a game. Mostly I want to stop being interrupted by cash grab game. It's irritating me, wearing me down. I want to stop thinking about it. It's exceptionally annoying. What the hell is this song? All right. No. Okay. That's the end of the stream. I will see you next week. Probably. Goodbye. Bye.